Engineering geology deals with pretty much everything within the civil engineering sphere. Everything we build is in contact with the earth, so we need to understand the nature and the performance of soils, rock, and then how those change in response to the presence of groundwater, surface water, and then natural hazards like earthquakes and volcanoes.
The PMEG program is teaching people the basics of rock mechanics, soil mechanics, teaching them about hydrogeology, which is the influence of water, and then it's looking at how this fits in to the engineering framework.
Can you place a structure on a piece of ground that's going to be strong enough to support its foundations? Are there any hidden or unknown hazards there? Could we be subject to an earthquake? And if there is, how's that ground going to respond? And then once we have that information, then we can provide information to the design engineers, the structural engineers, that allows them to build a structure that will withstand that particular hazard.
We'll be bringing people in from industry. We'll have engineers, engineering geologists, we'll have contractors coming in to talk to the students, and they're providing information about what their expectations are of the graduate.
The Professional Masters in Engineering Geology, it's a one-year program. It's a 180-point Masters, so it lasts for the full 12 months. And that involves 2 taught semesters where it's a mix of contact teaching through lectures and labs, self-directed learning and field trips integrated with that. The second part of the course is an individual dissertation project, and that lasts for about 4 months. So that's a project that the student will undertake on their own with support from the academic staff and usually partnered with industry. So all of our projects usually have some strongly practical aspect. We partner with both Quake Centre and Quake Core at the university. So we do a lot of work with the energy companies, looking at essentially maintenance of existing structures. So those will be dams and canals. Development of new infrastructure, so that's obviously roads. Quite often for energy infrastructure it can be renewable energy, so either geothermal or wind or some other means of producing energy. The program is very much a sort of hands-on practical program. There is almost an entire month through the one-year program where the students are taken out into the field, gaining hands-on experience and learning sort of practical professional skills that will be used throughout the sort of geotechnical industry. We've got this amazing field laboratory. We've got almost every geological situation you can think of within an hour or a little bit less from campus. So we have this fantastic opportunity. We can take the students out. We have field stations across the South Island. We partner with industry, and that allows us to visit current construction sites, globally iconic structures like Clyde Dam down in central Otago. We look at the road system, we look at the railway system, resource management and resource extraction, so really mining. We introduce the students to significant geohazards like landslides and fault rupture. Rather than having to sit and look at pretty pictures in a lecture, you can go out and actually feel and experience all of the things which are important to understand. The majority of our graduates are going straight into the consulting engineering industry. So those are full service, design, build and mitigate engineers. The vast majority of our students tend to stay in New Zealand. The other large job market is similarly consulting engineering in Australia, and then depending on commodity prices, mining in Australia. Secondary options for employment are both central and local government, and then a smaller group are probably going into the energy industry, working on essentially the maintenance of infrastructure, dams and canals, and then oil and gas.
The people who are suited to this degree are people who have the interest in what makes things work, the ability to innovate and to understand the context of the particular project.
We encourage applicants from anyone who has an earth science degree. That could be physical geography, it can be soil science, civil engineering, and really any other science discipline. If they have a good grasp of numeracy, they've got a mathematical bent, and they just have a natural curiosity in the natural world, how it works, and how to quantify it for engineering means. I think the majority of our students probably have a deep love for the outdoors, and this is not a career where you're going to be stuck behind a desk.